Ajit. So we are. So what do you think? We have to start with basics.
The notes I have, is it loading? Yeah, introduction, it's saying.
Yes. So you have sent me the file.
No, it's still loading.
Okay, so you can tell me what are hydrocarbons, Ajit? Hydrocarbons. What are hydrocarbons, Ajit?
Hydrocarbons?
Hydrocarbon. Simple thing.
Hydrocarbons are compounds with hydrogen and carbon.
Yes, compounds of carbon and hydrogen. And within these compounds, like there exist three main classes, which we call alkanes, alkenes, and alkynes. Someone on the door.
Okay.
Just give me 1 second. Okay, so hydrocarbons are like compounds of carbon and hydrogen only. Like when we are saying hydrocarbons, then they are only carbon and hydrogen compounds. So there's no other element in hydrocarbons. There's only carbon and hydrogen. And the organic molecules, basically we name them as that they are hydrocarbons. And
Okay.
like the organic molecules, they have like we use different formulas to represent them. Like for the other ones we have empirical and molecular formula. Same here, we have also we represent them with empiricals and molecular formulas. Like previously we did this, like for alkanes we use CnH2n plus 2, for alkenes it's CnH2n, and for alkynes it's CnH2n minus 2. Do you remember this? Like we have three classes: alkanes, alkenes, and alkynes. And what is the basic difference in between these three?
Well,
What?
they have one has double bonds and one doesn't.
Which one is having double bond?
Alkenes are having double bonds.
What about alkynes? What about alkynes, Wajid? Wajid, alkynes. What is the bond in between those alkynes? And what about alkene? Wajid, hello? What happened, Wajid? Hello? Can you hear me, Wajid?
Yes, I can hear you.
Okay, so I was asking you to tell me, like, what is the bond in between alkenes, alkanes, and alkynes? What is the bond in alkanes? Wajid, why are you not answering me? Hello?
Yeah, okay. Wait, I'm sending you the notes.
Just leave it. You can send me for tomorrow. Like, you can. We were discussing about alkenes, and okay, I just. Why don't you haven't sent me the downloaded PDF? Time. Okay, we will discuss those notes, but just tell me before, what is alkane? What is the bond in alkane?
Alkane is has a single bond. Single bonds. Alkenes have double bond, and alkynes have triple bonds.
Yes, and they have their formulas. Like the formula for alkane is CnH2n plus 2. Alkyne is CnH2n, and alkyne is CnH2n minus 2. N is the how many numbers of carbon atoms. Like if we have 3 carbons, it means that its hydrogen should be 2 into 3.
Hmm.
2 into 3 is 6 plus 2. How many hydrogens it should have? 8.
Hmm.
Okay, so these are the formulas that actually tell us, like in each alkene, alkane, or alkyne, how many hydrogens are attached to carbon atoms. Like this
Hmm.
is actually propane. So propane has 8 hydrogens, and for the same propene C3, it should have 6 hydrogens. And for propine, what happens? C3H 3 into 3 minus 2. So it's 6 minus 2, 4. Okay. However, it is the same pro- propane, like the carbon number is same, but hydrogen is different in each category. Like in propane, hydrogens number of hydrogens are 8. For propene, the number of hydrogens are 6. But for propine, why? Just because the bonds are increasing. So when the bonds are increasing, what happens? The hydrogens are decreasing. Getting this point? Like
Hmm.
number of bonds are increasing. Alkane has only single bonds. So number of bonds are increasing, and what happens? Like if you see the structure of propane, it's this 3 carbons. And how many hydrogens it has? 8. C3H8.
Yeah.
But if you see the like it's same 3 carbons, but now the bond is increased. Like we have one double bond in it. It's propene. So what happens? The number of hydrogens is decreased. Okay, so it's
Hmm.
now 3, 4, 5, 6. It has this is C3H6. So just having one double bond, the 2 hydrogens are decreased. Okay, and another double bond increases. You can see there's 2 other hydrogen atoms that are decreased. Like if you see 3. However, the number of carbons are same in each case. Are you getting this point, Wajid? Wajid, are you getting this point?
Yeah. Yeah.
Are you sure?
Hmm.
Like here, it's C3. How many hydrogens? 4. Only 4 hydrogens. So, are you getting this point? Like the carbon atoms are 3 in all these 3 cases, the one that I've just picked. So this 1, 2, and 3. All these 3 structures, they are having the same carbon atoms, same 3 carbon atoms. But the number of hydrogens is different in each case. Why? By increasing bonds, the number of hydrogen has decreased. So this alkane is having 8 hydrogen, alkene is having 2 hydrogen, and alkyne is having 3 hydrogen. Sorry, 4 hydrogen. 8, 6, 4, which means 2 hydrogens are decreased with each new bond forming or coming. So alkanes have single bond, alkenes have double bond, alkynes have triple bond. Is this clear? You can
Okay.
ask me any question if you find any confusion in any
No, that's
point.
clear.
Are you sure?
Yep.
So within like classes, like we have alkenes, alkanes, alkynes, we have other classes as well. Like we have benzene. Benzene is also the compounds of carbon and hydrogen. Okay, like they are actually arranged in the form of ring, a hexagon ring. So actually the molecular formula is C6H6, but this is arranged in the form of ring in which each corner is representing carbon. Like there are six corners and each corner is representing a carbon. There's like six carbons and six hydrogens.
Mhm. Okay.
Okay, this is benzene. So we discussed alkynes, benzene, and there's like macromolecules as well, like giant structures. We have trimethyl pentane, cyclohexane. So they all are actually the organic compounds.
Mhm.
And if you see this one, like when you are representing it by doubles and single bonds in a single straight chain formula, we say that this is the structural formula or it's the molecular formula. But when you represent it by showing the bonds in between the components, then it is its like skeletal formula. Okay, one is its structural
Okay.
formula in which you are just writing their um, number of carbons and hydrogens, like how many carbon and hydrogens are present. Basically, in organic chemistry, firstly we just draw the structural formula. Structural formula is just like this, the one I've shown you. That this is the C3H8, like it contains three carbons and eight hydrogens. Okay, so this is only the structural formula. It is not giving you the idea that it is alkane, alkene, or alkyne. Okay, you can check it by
Mhm.
formula, which is CnH2n plus 2. So how many hydrogens it has will give you the idea that whether it is
Okay.
alkane, alkene, or alkyne. But you can get the better idea by its skeletal structure. Like you're just opening the structure.
How? No, skeletal structure?
Skeletal, this one is the skeletal structure.
Oh, okay.
This one. Like you just have opened it and then you have drawn the bonds in it, the double bonds or single bonds. Like when you have the idea that these are the hydrogens, so you just have to draw those numbers of hydrogen. Like you cannot exceed from 8. So when you have drawn 3 carbons and you have drawn 8 hydrogens, then you will just get to know that there is no double bond in it. That's why each carbon is having one hydrogen attached to it. But when there's double bond, then it's like if you have been given C3H6, and what you have to do, you have to firstly draw the carbon atoms, three carbons, and then 6 hydrogens. One, two, three, 4, 5, 6. Like you just have drawn 6 hydrogens anyway. So now you have to completely satisfy the valency of carbon. You must know that valency of carbon is 4. Every time you have to, like previously when we were discussing about graphite and diamond, and in diamond we learned that it has tetrahedral structure. Okay, the compact arrangement is the one which has having tetrahedral structure. Tetra means it has 4 bonds. So every time 4 bonds should be satisfied with carbon, like one, two, three, 4. So we just have attached how many carbons? 8 carbons. Like which of the structures we were drawing? We were drawing this one, C3H6. This is C3H6. Like when you have given this formula C3H6, and you have just drawn
I
firstly
did.
the firstly you just have drawn the carbons, 3 carbons, and then 6 hydrogens, 1, 2, 3, 4, 5, 6. Okay, so now you have to set it like firstly you will see how many carbons, then you will see how many hydrogens, you will attach them in the skeletal structure, and then you see that if the carbon valency is satisfying in all these 3 carbons. So for this carbon is it's satisfying 1, 2, 3, 4. This carbon 1, 2, 3, 4. But for this carbon, it's only one hydrogen and one bond. Can you see this?
Yeah.
We have, it means there must be some double bond that is present. That's why it says that it has six hydrogens. So for that, like it's kind of tricky questions. Like you have to add the double bond here. Like when you are adding double bond, this carbon is exceeding in its valency 1, 2, 3, 4, 5. So this hydrogen you have to remove it. Are you getting this idea? Kind of confusing, and you have to attach it here. So then the valency will be satisfied for both carbons 1, 2, 3, 4, 1, 2, 3, 4. And this is how now the structure is okay. Is this clear? Are you getting this point, Wajid? I guess you
Yes.
are confused at some point about C3H6. I was saying yes, if you are confused at any
Yes.
point. Hmm? Yes, again, yes.
No, I'm okay. No, I'm not confused. This is an easy topic.
Okay, then just draw the structure of,
The structure of what? Tell me.
I'm telling you, C4H.
Will you keep using
Okay, just draw it on the screen. Now, just draw the structure of C4H6 on the screen.
C4H6?
Yes.
There's a mod. There's a copper. C4H6.
Yes, I've written this on the screen. This is the
Okay.
structural formula. You have to make the skeletal formula for it.
Fine. I'll unlock it. I'll unlock it when you want to come. Okay.
C4H6. Astaghfirullah, you have to satisfy the valency of carbons also. Allahu Akbar. What are you doing, Wajid?
What am I doing? Wait, I did something wrong.
You did the whole thing wrong.
Okay, wait. One, two, three, four, five. Wait. What did I do? Wait,
That
hold
was
on.
the thing I was telling you, and you was not taking interest into that.
No, wait. Shh.
Just saying it's so easy. It's pretty simple. However, it's not that simple.
It's not that deep.
It's very deep.
Wait. Stop running from me. Wait, okay, wait. Hold on. Let me redo it. Let me redo it. Stop running from me. Get the hell back over here. See? The ends have double double hydrogen. And then
First of all,
C
just
double.
draw four
Shh.
carbons.
Wait.
Okay,
Let
okay,
me
okay,
do
okay.
it. C. Bro, wallahi don't. Don't. Wait, hold on. Don't. Ah. No, don't. Seriously, don't. Don't. If you do, man, I'm gonna. Alright, man. When we wake up in the night, don't blame me if I did something in the fun. Alright. Alright, man. Alright. Wait. Hold on. Okay then.
I've given you the simple rule, and you will.
Oh yeah. Okay. Wait. Okay. I got it. Yeah. Okay. Is this correct? C4H6.
Uh, is it C4H6? Is it six?
Is six C4? There's six. Yes.
So you Google help you with this, or C4H6?
Is this correct? You say yes or no. We're telling him to say his first. Don't say mine. This is
Expecting it to
his.
be alkyne.
Okay, that's that spot.
I guess it should be alkyne. There must be some triple bond in
No, there's no triple bonds. I mean, there's no triple bond. No.
it. All the valencies are satisfied. I'm surprised how. It's alkene.
It's alkene. Yeah.
For alkene, alkene is alkane, alkene, alkyne.
Let's see what he said. No, it's not that. Okay, fine. You guys are good. All right. Did I do right? Did I do it correct?
I guess it should be alkyne, but you just made it alkene and you just
It's an
made it.
alkene. That's an alkene. C4H6 is an alkene. You know the formula?
Four,
CnH2n.
yes, C4. So four carbons and H6, which is like
Oh, it's an
2n.
alkene. Don't worry.
Four twos are 8 minus 2, 6. So it is alkyne, Wajid. How come it is alkene? When it is alkene, it should be like 8 hydrogens in it. It's alkyne. There must be some triple bonds in it. Wajid,
Mm-hmm.
are you getting my point that for alkyne, it should be C4H6. For alkene, it should be C4H8. This is alkene. And you made it alkene. But you should have to draw it according to alkyne. Why just because it's alkyne? It's not alkene.
I don't know how to make it an alkyne though.
Alkyne is like you are making triple bonds in between carbons. I'm surprised
Okay.
how it can be right in this way. There must be something wrong, which I am not able to pick. Four. So it's not simple. It's dialkene that you have made, like two double bonds. However, you have to draw only one triple bond in between the carbons. It is like the name given to it will be like 1, 2, 3, 4. It's like 1, 3 or 2, 4 butane. Yes, 2, 4 dibutane. Butene. Yes. Draw it according to alkyne, Vajid. Like make a triple bond
Uh,
between one of the carbon.
okay.
Where are you drawing?
There. I made a triple bond.
What have you done now? Just remove these carbons. Sorry, hydrogens. Just because now they are making valency 3, 5 valency for 2 and 3 carbon. However, it should be 4, not more, not less. Budget.
Mm-hmm.
the valency of carbon should be 4. So why it's 3, 4, 5? 5 with carbon number 2 and 5 with carbon number 3.
Mhm.
So now it's 3, 4. It's now C4H6. Are you getting this point? This is now alkyne. C4H6. Is this clear? The hydrogens
Okay.
that
Cool.
you have attached here, they were like making the valency of carbon to be 5. 3, 1 hydrogen that you have attached here, and one this 5, 5 for both of the carbons. That is wrong. So this is the actual structure. Is this clear now?
Yes.
Or
Mhm.
so we have halogenoalkanes as well. The only difference is that like instead of one hydrogen, like if we remove this hydrogen and attach chlorine here, then it becomes haloalkane or haloalkyne. Halo means halogens.
Okay.
Okay, halogens are halo. We call them halo. They are actually halogens. They are belonging to group 7A. Like they are fluorine, chlorine, bromine, iodine. All of
Mhm.
these, they are the halogens. So anyone, if you are attaching chlorine here, hydrogen instead of hydrogen, or bromine or fluorine, whichever you are going to attach, it will make this alkyne, alkene, or alkane to be haloalkane, haloalkyne, haloalkane. Okay, it's like we are just changing one of the functional group and the whole class changes. So basically we have three classes: alkanes, alkenes, and alkynes. And further we are just changing the functional groups and we are making new classes out of it. Like we just have removed one of the hydrogen of alkane and it will make haloalkanes. If we remove one of the hydrogen of alkene and attach halogen there, then it will become haloalkene. And if you just remove one of the hydrogens of alkyne, then it will make alkyne. Are you getting this point?
Mhm.
What does this mean? That you are not getting any
Hello,
idea.
alkyne.
Yes, haloalkyne.
Hello,
Yes,
alkyne is a combination of alkynes and halogens.
yes. Like we have simple alkyne and we just remove, substitute means like we are just removing one of the hydrogen which is attached to carbons, and like at place of that hydrogen we are attaching any of the halogen, which is chlorine, fluorine, bromine, iodine. Okay, so if you are attaching any of the halogens at the side of hydrogen, then it will become haloalkane or alkene or alkyne. Okay, the same case, like if you are
Okay.
removing one of the hydrogen and attaching OH to that, then it will make alcohol, like ol.
Okay.
Like you have the simple alkane and you are adding OH at the end, then it will make, like if it was methane previously, methane, which is CH4, the simplest alkane. Okay, and this is these are all hydrogens that are attached to it. If you are removing this hydrogen and attaching chlorine to it, then it will become chloromethane. Okay, and apart from chlorine, if you are adding OH, then it will become what it become, like instead of reading "ane" we will read it as "ol." So it will become methanol.
Oh, okay.
Are you getting this point, Wajid? Like we
Yes.
are
Yes.
substituting the hydrogens and we are adding other functional groups and the whole class changes. Like we just added halogens and it becomes haloalkanes. We just added OH and becomes alcohol. Okay. The same way
Mm.
we have aldehyde, which is CHO. Okay, like if we have CHO group at the end, then it becomes aldehyde. So it's like butane and it becomes butanol. Butanol is one of the aldehyde. Okay, it's like
Okay.
aldehyde is having this functional group. C double bond O H. These are aldehydes. Like we call it as CHO. Like this is the functional group at the end. And if we have at one side we have methane and at the other side aldehydes, sorry, we have formaldehyde. This when both at both sides when hydrogen is present we call this as formaldehyde. Okay, formaldehyde. This is also one of the class of
Mhm.
hydrocarbons. And if at one side